The Sun is the central star of our solar system, a blazing ball of energy that fuels life on Earth. It's primarily made of hydrogen, about 75%, and helium, about 24%, with trace amounts of heavier elements like oxygen and carbon. It is so massive, about 109 times the diameter of Earth, that it contains 99.86% of the entire solar system's mass. The Sun's gravity is what keeps everything in our solar system, from the planets to comets, in orbit. But the Sun isn't just important for keeping us in orbit, it's our life-giving energy source. Without it, Earth would be a frozen, lifeless rock drifting in space. But how does this fiery star work, and why is it so powerful? The Sun's structure and energy production. At the core of the Sun, nuclear fusion occurs. This is where the magic happens. Under extreme pressure and heat, about 15 million degrees Celsius, hydrogen atoms collide with each other and fuse together to form helium, a process that releases an enormous amount of energy. This energy, in the form of light and heat, is what powers the Sun and provides the energy that eventually reaches Earth. But this energy doesn't just shoot out to space immediately, it takes a long journey. After being produced in the core, energy travels outward through the Sun's radiative zone, where it moves by radiation. The process here is incredibly slow. It can take up to 100,000 years for the energy to move through this zone. Once the energy reaches the convective zone, things speed up. In this outer layer, heat is transferred by convection currents, where hot plasma rises toward the surface, cools down, and sinks back toward the interior. This movement helps transfer energy from deeper layers to the Sun's outer atmosphere. Now that we know how energy is created and moves through the Sun, let's look at the different layers we can observe. The photosphere is the Sun's visible surface, but it's not solid like Earth's surface, it's actually a layer of gas that emits light. The temperature of the photosphere is around 500 degrees Celsius, which is hot enough to radiate the light we see from Earth. Above the photosphere lies the chromosphere, which is a thin layer that gives off a reddish glow during a solar eclipse. But the most mysterious part of the Sun is its corona, which is the outermost layer. The corona is made of extremely hot plasma, surprisingly hotter than the Sun's surface. While the photosphere is around 500 degrees Celsius, the temperature of the corona can reach between 1 to 3 million degrees Celsius. Scientists are still trying to understand why this outer layer is so much hotter than the surface. One theory is that magnetic fields on the Sun cause the corona to heat up, creating solar winds that stretch far into space. The Sun isn't just a glowing ball of light, it's constantly active and produces powerful bursts of energy that affect not just space, but our planet as well. One of the most noticeable features on the Sun's surface are sunspots, dark patches that occur because of intense magnetic activity. These sunspots are cooler than their surroundings, but they can tell us a lot about the Sun's magnetic field and activity. The Sun goes through an 11-year cycle where the number of sunspots rises and falls. During periods of maximum sunspot activity, the Sun is also more likely to produce solar flares, explosions of energy that send massive amounts of radiation into space. These flares can disrupt communications and GPS systems here on Earth, especially when they're aimed directly at us. Another form of solar activity is coronal mass ejections, CMS. These massive bursts of solar wind and magnetic fields are released from the Sun's corona and travel through space. If ACME is directed at Earth, it can trigger geomagnetic storms, which can cause beautiful auroras in the sky, but also wreak havoc on satellite communications, power grids, and other technology-dependent systems. Understanding solar activity is essential for predicting space weather and protecting our technological infrastructure. The Sun's energy is vital for life on Earth. Every day, the Sun radiates billions of tons of energy, and without it, Earth would be a cold, lifeless planet. The Sun powers photosynthesis, the process that allows plants to create food and produce oxygen, which sustains most life forms. The Sun also drives Earth's weather systems, creating wind, ocean currents, and the water cycle. Without the sun's heat, our planet would be frozen and our weather systems would not exist. The sun also plays a key role in the changing of the seasons. Earth's axis is tilted, and as our planet orbits the sun, the angle at which sunlight strikes different parts of the planet changes. This tilt and the Earth's orbit result in the seasons winter, spring, summer, and fall, each with distinct weather patterns and temperatures. Beyond just the weather, the sun's gravitational pull keeps Earth and all the other planets locked in orbit. This stable orbit allows Earth to maintain a consistent climate, ensuring that life can continue to thrive. Like all stars, the sun has a limited lifespan. In about 5 billion years, the sun will exhaust the hydrogen in its core, causing a dramatic shift in its behavior. When the hydrogen runs out, the sun will begin to fuse heavier elements, and its core will contract while its outer layers will expand. This transformation will cause the sun to swell into a red giant, becoming so large that it could potentially swallow Mercury, Venus, and possibly even Earth. During this phase, the sun will lose much of its mass, shedding it into space. Eventually, the sun will expel its outer layers and shrink down to a small, dense remnant known as a white dwarf. Over billions of years, this white dwarf will gradually cool down and fade away. While the sun's future may seem distant, it's a reminder of the life cycle of stars, and it underscores just how temporary everything in the universe truly is. Even as the sun's end approaches, it will leave behind the elements necessary for new stars, planets, and possibly life to form elsewhere in the cosmos. Despite being just one star in the vast universe, the sun is the most crucial to our existence. Understanding its structure, energy, and future helps us better understand not only our solar system but also the life cycles of stars throughout the galaxy.